What if Australia had an inland sea right in the middle of the continent? What if the driest inhabited continent on Earth could be reshaped by dams, tunnels, and redirected rivers? In 1938, John Bradfield proposed exactly that. A plan to revive Australia's arid heart with a massive artificial lake. Known as the Bradfield Scheme, it was one of the most ambitious engineering ideas of its time. But why was a massive inland sea imagined in the middle of the continent? Born in Queensland in 1867, John Job Crew Bradfield, one of Australia's most respected engineers, was known as the father of the Sydney Harbour Bridge. Designed in the 1920s, it was the longest arch bridge in the world at the time and became an engineering marvel that transformed Sydney. Bradfield was also the mastermind behind Brisbane's Story Bridge. Across his career, he worked on railways, water systems, and urban planning. Educated at the University of Queensland, earned the first engineering doctorate from the University of Sydney, and became known as the father of modern Sydney. Bradfield knew Australia's geography intimately. The coasts were fertile, the interior was dry, harsh, and often nearly empty. He spent years wondering whether that imbalance could be corrected. By the 1930s, nearing retirement, he unveiled his biggest dream yet: redirect monsoon-fed rivers from northern Australia into the center of the continent and create what he called green valleys in the interior. Could the wet north be turned into a lifeline for the dry middle? His plan was simple to describe and enormous to build. Bradfield wanted to capture the Tully, Herbert, and Burdekin rivers, which rise on Queensland's coast and flow eastward, then divert them west of the Great Dividing Range. From there, the water would be channeled into the Thomson River and eventually southwest to the usually dry Lake Eyre basin. In theory, the result would be a giant inland reservoir, an inland sea for Australia. Project maps showed the route clearly. Monsoon river water pushed through dams, pipes, and tunnels until Lake Eyre began to fill. Australia is one of the driest places in the world. Around 70% of its land area is desert or semi-desert. Most of the population lives in coastal cities like Sydney and Melbourne, while the interior remains sparsely populated and often unproductive. In the 1930s, the Great Depression was still biting, drought was hitting farmers hard, and the livestock industry was under pressure. So what if the center could be irrigated? What if the empty middle could become productive? Supporters claimed the benefits could be enormous. The scheme was said to be capable of creating more than 7,800 square kilometers of new farmland in inland Queensland, roughly equal to 9 million football fields. With irrigation, supporters imagined cotton, sugarcane, grain, and orchards spreading across country long considered too dry. Food production could increase, exports could strengthen, soil erosion might be reduced, and the spread of desertification could be slowed. The major dams were also projected to generate around 370 megawatts of electricity annually. So could a large inland body of water improve the climate itself? Some officials argued that replacing hot, dry ground with a vast, heat-absorbing water surface might lower regional air temperatures and even alter rainfall patterns. Beyond that came talk of tourism, recreation, biological production such as algae farming, and even the possibility that diverting part of Queensland's floodwaters inland could reduce flood risk on the coast. Taken together, it sounded like a different future for Australia. The country was still shaping its identity. In the late 1930s, giant infrastructure projects carried emotional power. Bradfield's vision offered water, fertility, climate relief, and new agricultural land. But could one idea really overcome the continent itself? Bradfield presented the plan to the Queensland government in 1938, and at first it stirred excitement. Newspapers ran headlines about greening the desert. Politicians were intrigued by the language of national development. Bradfield's reputation gave the scheme credibility, but then came war. In 1939, World War II began, and Australia redirected its resources toward defense. Dams gave way to tanks, tunnels to trenches. Even after the war, the cost remained daunting. Bradfield's own estimates ran into billions of pounds, a staggering sum for that era. The reaction was mixed. Some scientists and engineers supported the idea, and Queensland farmers hoped it could work, but the critics multiplied. Geologists argued there simply was not enough water. Northern rivers did receive heavy rainfall, but the journey inland was long, and some estimates suggested that up to half the diverted water could evaporate before it arrived. Hydrologists warned of salinity. Transferred water could salt the soil and ruin crops. Geography posed another obstacle. The Great Dividing Range stood between the source rivers and the interior like a wall roughly 1,000 meters high. Could water be forced over or through it? Technically, perhaps, cheaply and safely, that was another matter. One of the sharpest critics was Professor G.W. Leeper of the University of Melbourne. He argued that Bradfield's plan lacked scientific basis and was not supported by adequate data. Measurements from the 1930s were limited, and barometric elevation estimates could be misleading. As time passed, the practical problems became harder to ignore. In 1947, a technical review led by W.H.R. Nimmo found that Bradfield had overestimated river flows and available water. The usable water figures were far too optimistic. Nimmo's review also concluded that the costs and technical challenges would make the scheme extremely difficult to carry out. It was the first major institutional blow to the project. The sheer scale stretched the limits of the era. The scheme would have required hundreds of kilometers of pipelines, thousands of pumping stations, and massive dams. Construction technology simply was not yet suited to such vast pipe and pump systems. Bradfield died in 1943, only 5 years after first presenting the scheme. But the idea did not die with him. It resurfaced in the 1950s and 1960s. In 1981, Queensland's opposition proposed a new Bradfield version. In 2007, Premier Peter Beattie called for another review, though by then attention was shifting toward alternatives such as desalination rather than huge dams. In 2019, some federal political leaders again asked for the plan to be reevaluated, and that same year, Queensland's opposition defended it as a long-term strategic investment. Why did it keep coming back? Because drought had always been a major problem in Australia. Modern science, however, has looked at the scheme far more coldly than politics has. A Queensland government report published in December 2022 effectively scrapped the idea. It concluded that despite the enormous infrastructure cost, the available water supply would still be insufficient. Estimated costs exceeded $30 billion. Its conclusion was blunt. If there is consistently insufficient water, no Bradfield plan can work. In other words, the scheme was unfeasible. CSIRO, Australia's national science agency, reached a similar conclusion in a 2020 analysis. It found that while transporting water over such distances may be technically possible, the infrastructure required would be economically unviable. The research also found that the maximum amount of water that could be taken from the north was much less than Bradfield's estimates, about half. Its broader conclusion was that using water close to where it falls is much more effective for regional development. That is why modern thinking favors smaller mini-water grids near the coast rather than giant inland diversions. Even so, Bradfield's legacy did not vanish. The impulse behind the scheme lives on in smaller, more practical projects. Aquifer regeneration, seasonal ponds, water management on coastal plains, renewable energy-powered pumping pilots, and wetland restoration. These approaches aim for some of the same benefits with far lower risk and far more manageable cost. Instead of one giant leap, the modern answer is many smaller ones. Still, Australia's interior remains vulnerable to drought, and that keeps the old question alive. Could future advances in technology, climate knowledge, or water management reopen the debate in a different form? For now, experts are clear that a mega project to create an inland sea is off the table. Yet politics is unpredictable, and water crises have a way of reviving old dreams. So perhaps that is why the Bradfield scheme still fascinates people nearly a century later. It was a challenge thrown at geography itself. What if distance, heat, and drought were not permanent limits, but engineering problems waiting for a solution? For now, the answer is clear enough: not very likely. But John Bradfield's boldest vision still lingers over the red interior like a mirage, impossible to build, and somehow still hard to forget. Thank you for watching, and see you in the next video.